Hello, welcome back once again to this current section. This is section 4 of unit 4, and we are going to look at the net present value method. Right, so in our previous sections, we looked at how to use the ARR, we've looked at how to use the payback period to do your investment appraisal. So today is going to be NPV method. So at the end of this section, you should be able to use the NPV or the net present value method to select mutually exclusive projects. You also use the internal rate of return method to select mutually exclusive projects. Your ability to use the PI method, of course, to select projects. Okay, so our main focus will be on the net present value method. Alright, so what is NPV? So NPV talks about the present value of a project cash inflows minus the present value of the initial or subsequent cost. So it's a measure of how much value is created or added by the manager by undertaking new investment. Alright, so NPV is simply the cash inflows that we are going to get from the project. How much is the project giving you? Alright, then you less the initial amount. So you find the present value of these future cash flows that you are getting from the project. Or yeah, then you less your initial amount that you invested in the project. Then you get the net present value. Alright. Yeah. Of course, the initial amount is in its present state already because it was invested at day zero. There can also be initial amount invested from the subsequent years. It's not always in year zero that you maybe as the project is ongoing, you invested new amount into the project. You have to find the present value of all these cash flows. Then you find the net of it. So that is what we term as the net present value. Alright. So it's regarded as the best method for investment evaluation or investment criteria. If you want to select an investment, the NPV will be the best investment decision criterion. Alright. So what is the decision rule when it comes to NPV? Don't forget the decision rules, please. It's very important when you are evaluating projects. Alright, so the project must either be independent or mutually exclusive, or the one that is any of these the rules apply to every project. So one, for independent or single project, accept the NPV if the NPV is greater than 0, and the reverse is true. So you reject the project with negative NPV. So if the NPV is greater than 0 means that you have to get a positive NPV. Alright, so if the NPV is negative, it means that you are getting a loss. Alright, what you are investing in the project is more than what the project is giving you, so you have to reject it. But for mutually exclusive projects, you have to accept the project with the highest NPV. Okay, let's say you have more than 2 projects and they are all giving you positive NPV. Which one should you choose? You have to go for the one with the higher positive NPV, and of course, anything you reject the other one. Alright, let's try with this question. So Amakom Limited is considering whether or not a new consumer project should be launched. So based on projected sales and costs, we expect that the cash flows over the 5-year period will be 2,000 in the first year, 4,000 in the next year, and 5,000 in the last year. Alright, so we have 3 years. So we have 5 years. So 2,000 in the first 2 years. So in the first 2 years, year 1 and year 2 is 2,000, 2,000. Okay, in the next 2 years again, we have 4,000, and the last year is 5,000. So we have 2, 2, 4, and 4 and 5. Alright, so it will cost about 10,000 to begin the production. So that is the initial amount that we are investing in the project. So we use a 10% discount rate to evaluate new projects. So that is the cost of capital that you are going to, or the discount rate that you are going to discount the various projects into their present state. Alright, so of course I've taught you how to discount or convert figures from their present value or from their future value to their present value. We have done it in our subsequent unit, or sorry, in our previous unit. We treated how to convert features from their future value to their present values, and also from their present values to their future values. Alright, so let's see how we are going to go about it. Good. So we've tabulated it so nicely so that so anytime you are solving a question like this, if the years spans more than 2 years, of course you can do it in a tabular form. It makes it look nicer and simpler. Yeah. So we have years 0 to 5. All right. So the initial amount was invested at year 0, and these are the cash flows that are associated with it. So we have 2,000, 2,000. Also in year 3 and 4 we have 4,000, and year 5 to be 5,000. So they give us a cost of capital or a discount rate of 10%. Alright, so you find your discount factor using the discount factor formula. Okay, so the formula is 1 over 1 plus r, or into bracket exponent n. Okay, so n represents the number of year or number of period. So if you are in year 1 or year 0, it will be 1 over 1 plus 0 or exponent 0. Any number raised to the power 0 will give you 1. So 1 over 1 will give you 1. That is why we are getting 1 here. So you do same for year 1. So we just change the n to 1. Okay. Yeah. Your r is 10%, so you are good to go. So when it comes to year 2, you change n to 2. You do same for year 3. You change n to 3 through to year 5. So those will give you the discount factor. So your present value will be your cash flows. So here is 10,000. It's in bracket because it's negative. That is a cash outflow. The amount we are rather investing in the project, so it's a cash outflows, and the cash inflows are the positive figures. All right, so we multiply each of them by their discount factor. This one to this. We multiply each of them by their discount factor. So this to this. So those will give you the present values from year 1 to year 5. Alright, so the net present value is the present value. So summation of all from year 1 to 5 will give you the present value. Then you less the year 0 cash outflow from it. Then you get your net present value, which is given here. So this is your net present value. Of course, it's a positive figure, so we accept the project. Let's also look at profitability index. So profitability index relies on the ratio of the present value of future cash flows to the present value of the initial investment as a way of determining the viability of an investment option. So if you are using the profitability index also as a measurement or a criteria for investment decision, right? The formula is the present value of the project investment over the initial investment. So the present value of the cash flows associated with the project over your initial investment. All right. So the present value. So if the project has 5 years and each year you're going to get 1,000 cedis, you find the present value of all these cash flows, future cash flows associated with the project. You divide by the initial investment, then you get your profitability index. Alright, so if you looked at the previous example that we solved, we had an NPV of 23003.81. Of course, you don't need the NPV. The NPV is like the PV minus the initial investment. This one we need the PV. Alright, so we add the 2, then we get a PV. Okay, you can also go back and add all the present values from year 1 to 5. Alright, so we add them. So it will be 23,008 plus 10,000. We divide by 10,000 and we get 1.2303. So this is the profitability index. So what is the decision rule when it comes to profitability index? So a project is acceptable if the PI is greater than 1.0. We are dealing with so many decision rules, so make sure you understand each of them so that you don't contradict. So when it comes to PI, we accept a project if the PI is greater than 1.0. And the higher the PI, the higher the project's ranking. So if you have 4 projects, you have to rank them based on the highest PI ratio. So you rank them from the higher to the lower. Alright, any ones that your amount can invest, then you choose those ones. Alright, so this is a question here for you. It's very long, but it's simple. You can do it. Alright, so the requirement is to calculate the NPV and PI for each of them and the one that you recommend. Alright, thank you, and I will see you in section 5.